For number 6 through 9, you are going to solve using the quadratic formula. So again, this is where we're going to find the discriminant first and then plug into the quadratic formula. The reason you want to find the discriminant first is because if it's negative, you do not have to continue, so you do less work. And we know that most of you love to do less work. So for number 6, we have A, B, and C. For your discriminant, we are going to have 4 squared minus 4 times 1 times 2. So this is going to be 16 minus 8, which is going to give us 8. So we know that we should have 2 solutions for this. So when we plug into the quadratic formula, we are going to have x equals negative 4 plus and minus the square root of 8 all over 2 times 1. And again, you always want to check to see if that square root can break down. The square root of 8 does, because there's a 4 in it. So this becomes 2 square root of 2. So we have x equals negative 4 plus and minus 2 root 2 all over 2. And then again, just like number 1 at the very top, if you did want to take these a step further, you would simplify, because all of these can be cut in half, and then you would end up with x equals negative 2 plus and minus 1 root 2 over 1. And you don't even have to write those ones there if you don't want to. On your test, your short test that you're going to take next week, if you left this as your answer, that would be perfectly fine. I'm not expecting you guys to simplify just because we are under strange circumstances. All right, so for number 7, you're going to do the same thing. Start out with the discriminant. So we have B, A, B, and C. So you're going to have 7 squared minus 4 times negative 2. 7 squared is going to give you 49 minus 4 times negative 8, because that's what these are. So then you have 49 plus 32, because negative times negative gives you a positive. And then that is going to give you 81. So again, we should have 2 answers for this because your discriminant is positive. So when you plug this in, you have x equals negative 7, because your b is positive 7, plus and minus, the square root of 81, all over 2 times 4. Now, 81 is a perfect square, so this is going to turn into just a 9. So when you rewrite this, you have x equals negative 7 plus and minus 9 over 8. And then this is where you actually want to split them up. You are going to have x equals negative 7 plus 9 over 8. And if you plug this in your calculator at once, you want to put parentheses on the top, or it's not going to work. It will divide first and then add, and you don't want that. This is going to give you 1/4. And then you're also going to have x equals negative 7 minus 9 over 8. Same thing. Put that in parentheses. And this is going to give you negative 2. So here are your 2 answers that you would have. For this, you cannot leave your answer like this, because they are all whole numbers. You should be able to simplify and reduce. All right, so if it is a situation where your square root is a perfect square, you do want to split it up and get those 2 different answers. So for number 8, we are going to do the same thing. You have A, B, and C. So we have 6 squared minus 4 times 1 times 3. 36 minus 12. And this is going to give us 24. So again, 2 answers. And you always, always, always want to see if that square root can break down. So we're going to have x equals -6 plus and minus square root of 24 all over 2 times 1. I'm going to move this up a little bit. Now, square root of 24 does break down because it's 6 times 4. So off to the side somewhere, we have a 4 and a 6, so this becomes 2 root 6. So we have x equals -6 plus and minus 2 square root 6 over 2. And just like before, these can all reduce. So you would have x equals -3 plus and minus 1 root 6 over 1. And either of these answers would be fine. Again, I'm not expecting you to reduce just because you haven't really seen this in person yet. All right, and then the last one for quadratic formula. This one's important because we always want to make sure that they are set equal to 0 first. So we need to get that 7r over to the other side. So you want to add 7r to both sides first, and then we always want them in standard form. So you're going to have 2r squared, and then put that plus 7r in between, plus 3 equals 0. And now you can start, you have a, b, and c. So you'll do your discriminant, b squared minus 4 times a times c. So we have 49 minus 4 times 6. So 49 minus 24, and that is going to give us 25. So then when you plug into the quadratic formula, you should have x equals, sorry, -7 plus and minus the square root of 25 all over 2 times a. And the square root of 25 is just a 5. So for this one, it's going to act very similar to number 7. You're going to want to split it up and get those two separate answers. So we have -7 plus and minus 5 over 4. So -7 plus 5 over 4. This is going to be -2 over 4, or just -1/2. And then we are going to have -7 minus 5 over 4. And again, if you're putting it in your calculator, you want to make sure you have those parentheses. And this is going to simplify to -3. So there are our two answers. Okay, so a lot of practice for quadratic formula. Hopefully this video helps you a little bit if you got stuck along the way. We have a couple more left. We'll see how far we can get because I can only make videos up to 15 minutes. And you guys would be bored to tears by that point anyways. So square root of 28, I believe we already simplified this somewhere on here. 28 is going to be 4 and 7. And the square root of 4 is 2. Oh my goodness, I'm so sorry. So this turns into 2 root 7. For 108, I believe the biggest perfect square that goes into this is 36. Let me check. Yep. So you have 36 and 3. So this turns into be 6 root 3. And again, if you are not getting these numbers, just try dividing by a bigger perfect square. Look at that list or make yourself a new one. You guys know how to do this. And then start dividing from the bottom of that list up, and eventually you'll get to the biggest one. And then for 18, we know that 9 times 2 gives us 18. 9 is a perfect square, so this becomes 3 root 2. All right, 2 more problems left. For number 11, it wants us to find the discriminant. So this is where we're going to do b squared minus 4ac. But again, we want to make sure it's set equal to 0. So we need to bring this 2x over to the left-hand side. So we are actually working with negative 6x squared plus 2x plus 3 equals 0. And now you have your a, b, and c. So we have 2 squared minus 4 times negative 6 times 3. So this is going to be 4 minus 4 times negative 18. And then negative 4 times negative 18 gives us positive 72. So our discriminant is going to be 76. If it just asks for the discriminant, this is all you have to do. But if it's like number 12, where it asks you to determine the number of solutions, then you need to tell me, based on your discriminant, what does that mean? Am I going to have 1 solution, 2 solutions, or no solutions? So for number 12, you're using the same equation as 11, this discriminant, and it's already set equal to 0. So you have your a, b, and c. So you would do 7 squared minus 4 times negative 2 times negative 3. 7 squared is going to give you 49. Negative 2 times negative 3 gives you positive 6. So then you have 49 minus 24. This is going to equal positive 25. Since it is positive, that means that there are 2 solutions. So this would be your answer. All right, so that is the entire review. Again, I will post the written solutions as if this was a normal quiz and I was posting the answers online. And then from this, if you still have further questions, please, please, please let me know. Several of you have been emailing me. It's been working out really well. Or you could always post in Google Classroom and see if anyone else can answer your question too.